So this is the 8th problem from Irodov's book on problems in general physics, and the problem statement is as follows. Two boats A and B move away from a buoy anchored at the middle of a river along the mutually perpendicular straight lines. The boat A along the river and boat B across the river. Having moved off an equal distance from the buoy, the boats returned. Find the ratio of times of motion of boats, tau A by tau B, if the velocity of each boat with respect to water is 1.2 times greater than the stream velocity. So let us just draw a diagram to visualize this. So here we have a buoy which is located at the center of this river, in the middle of the river, and we've got two boats, and there's boat A and boat B. So they go so boat A goes from this point O, so it goes from point O to this point, and I'm calling this point A, and the boat B goes from point O to the point B. The distance traveled by both boats, the distance of these points A and B, they are same, so that is equal to D. So OA is equal to OB is equal to D. So this is the one equation that we have. And the second thing that is given to us is that the velocities of these boats are equal to 1.2 times the velocity of the river that we have here. So the velocity of the river is V naught. So this is V naught, this is the velocity of the river, and the velocity of boats A and B with respect to so their absolute velocities are 1.2 times the velocity of this river. Now what we have to find out? We have to find out tau A divided by tau B. So tau A is the time taken by boat A to go from point O to A and then back. Similarly, tau B is the time taken by boat B to go from point O to point B and then back from point B to O. So let us first try to find out these times, tau A and tau B, for both of these boats individually. So let us take the case for boat A first. So let us consider the boat A first. Boat A goes from point O to this point, and I'm saying this is point A. So it goes to this point and then it comes back. So the absolute velocity of the boat, let's call it VA. So on its journey from O to A, the absolute velocity is VA, and the velocity of the stream is V naught. So the resultant velocity, we call it VRA1. This is equal to the sum of both VA and V naught. So because the velocities are in the same direction, so it is a simple addition of the two velocities. Similarly, when it goes from point A back to point O, the relative velocity VRA2 will be equal to the velocity of the boat, the absolute velocity of the boat, minus the absolute velocity of the river. So now, in order to find out the time, tau A, let me use a different ink here. Okay, so tau A will be equal to the distance. So let's say the distance is D. So from point O To point A the distance is D. So basically I'm assuming that OA is equal to D. So tau A will be equal to D divided by the velocity. And the velocity will be VA plus V naught. So this is the time it takes to go from O to A, and to go back from A to O, the time it will take will be equal to D divided by VA minus V naught. Now it is already given to us that VA is equal to 1.2 times V naught. So tau A will be equal to D divided by 2.2 times V naught plus D, and over here we'll get 0.2 times V naught. So the total time tau A will be equal to 1 divided by 2.2 plus 1 divided by 0.2. On solving, we'll find out that this is equal to 0.45 and this is equal to 5. So this is the time taken, the total time taken by boat A to go from point O to A and back from A to O. So this is the total time taken by boat A. Now let us consider boat B. So on its journey from point O to point B, the boat will not go along the line OB. It will actually travel at a certain angle, and then due to the effect of the velocity of river, it will travel the path from O to B. So its velocity is going to be, so this is velocity VB. So this is along from at a certain angle theta. So this is VB, and we have V naught, which is the velocity of river, and this is the resultant velocity as the boat goes from O to point B. So this is VRB1. And what is the magnitude of VRB1? We can use Pythagoras theorem for that, and that will be equal to VB square minus V naught square. VB will be equal to 1.2 times V naught minus V naught square. We get a value of V naught under root 0.44. Now let us see how this velocity will be affected when the when boat B goes from point B back to point O. So this is point B, this is point O. So the boat will actually move in this direction. This is velocity VB, the absolute velocity of the boat. And because the river is also flowing at a velocity V0, we get a relative velocity VRB2. Again, we can use Pythagoras theorem to find out the magnitude of VRB2 will be equal to VB square minus V0 square. So this will give us the same equation that we got earlier. So this same equation that we got here, we'll get the same thing here as well. So this is going to be V0 multiplied by 0.44, under root of 0.44. So the velocity of boat B as it goes from O to B and B to O is going to be constant. It's going to be the same velocity. So now we have to find out the time taken by B. So the time taken by B will be equal to D divided by VRB1 plus D divided by VRB2. Now since RB1 and VRB1 and VRB2, that is the same thing, we can write it as 2D divided by V0 under root 0.44. So tau B is equal to, once again we'll take, and here we have 0.44. Upon solving, we get 3.02 times D by V0. So this is tau B. Now we already got tau A as 5.45 times D by V0 and tau B is equal to 3.02 times D by V0. So this is the value tau A that we previously got. The value of tau A was 5.45 times D by V0, and tau B we have now obtained its value as 3.02 times D by V0. So now if we have to find out tau A by tau B, so that is the time taken by A in this entire journey and time, and the ratio of time taken by A and the ratio of time taken by B on this journey, we can just the D by V0 term will cancel out for both of them. We get 5.45 divided by 3.02, and this will give us a value of 1.8. So this is our answer for the problem 1.8 in Irodov's book. Thank you for watching, everyone, and if you like the content, then please like this video, share it with your friends if you find it useful, and please subscribe to my channel. Thank you.